Hello, and welcome to the video lecture comparing the different file organizations. So we always have to think about the factors involved. So one is storage space, the other is retrieval, and there are different kinds of retrievals. So we could be retrieving on the primary key in a sequential manner. We can be randomly retrieving primary keys. We might have to retrieve based on multiple key values. And then there's data updating. So we've got storage space, then we have data retrieval, and then we have updating data. So we're either deleting records, adding new records, or updating records. And how do these different file organizations handle that? So when it's sequential, there is no wasted space. We've seen that. We just add data as it goes in. If it's indexed, there's no wasted space for data, but there is extra space allocated to maintain the index associated with that. So remember, I can store the data sequentially. I can store the data sorted when it comes to indexed. And then if it's indexed, I have to set aside extra space because for all intents and purposes it's an extra table associated with the index. So there is more storage space associated with the indexed. And then when it comes to hashed, remember it's just an algorithm. So extra space may be needed to allow for addition and deletion of records after the initial set of data is loaded. That's to avoid, or as much as possible, having to shift all of the records down when I need to insert new records. So I may, when I'm designing a hashed table, a hashed filed table, I may, when I initially set it up, leave extra space in some of the pages to allow for more data to be inserted before I have to go and reorganize. In every case, you're going to be reorganizing one way or another, but we're going to try to minimize that. So now, if I'm looking for, if I'm sequentially searching through these records on the primary key, if it's sequential, it's very fast, again, because the primary key is sequential. In the indexed, it's moderately fast. Again, I have to go to the index before I can find the data. But unless I'm using a hash index, doing a sequential run through a hash table is just impractical. That's not the purpose of setting up the hashed table. In order to search the hash table, you want to use the hashed algorithm. If I want to do a random retrieval on the primary keys, sequential is impractical because, again, I'm more than likely going to have to search through the entire table because I don't know what order this thing is in. So if I'm doing a random retrieval, I don't know how to find it directly, so I have to look through everything. If it's indexed, it's moderately fast. Remember the tree structure, or what I refer to as the bush structure because it's supposed to be short and fat. So that's going to be moderately fast because I only have to go down as many levels as there are in the index. So that's going to be pretty fast. And then again, the hashed is using the hashed algorithm, so I'm running through that table very, very quickly. If I've got multiple keys, again, it's possible, but again, I'm going to scan the whole file, pretty much exactly the same as the random retrieval on a sequential file. If I'm indexed and I'm looking for multiple keys, it's very fast as long as I have multiple indexes to search through. If I'm still stuck searching through one index, then it's going to be only as fast as scanning through the index. And again, since it's unless I'm using a hashed index, doing multiple key retrieval is impossible with hashed data. So now, that's retrieval. So now let's talk about update. So if I delete records from a sequential file, I'm creating wasted space, right? Which eventually is going to require rebuilding or reorganizing. If I'm deleting records in an indexed file, it depends on if I'm dynamically allocating space or not. It's easy, but again, the maintenance happens on the index end. not necessarily on the file end, because the file, we can store the data anyway in the index file, so we can delete them out. But again, they're always going to require reorganizing. And deleting records in hash is very easy. I just use the hashing algorithm, find the record, and delete it. If I'm adding new records, if it's sequential, again, it's rewriting the file. If I have to slip, if it's ordered, I have to slip that record in. I have to move everything down, which means I basically have to rewrite the file. Adding new records in an index, again, it depends on if the space is dynamically allocated. But again, it's the maintenance on the indexes. And I'm adding new records to a hash file is very easy, but multiple keys require extra work, right? So the hashed algorithms, there can be multiple hashed algorithms for the same table. And then updating the records, again, with sequential, we're rewriting the whole file. With indexes, I'm maintaining the indexes, and with hashed, I'm going right to the record and just updating it. And that is the end of the comparison on the different file organizations.